Hello, my name is Adam Linder, and I work on the BigFix team at HCL. Welcome to the third and final video in our ActionScript 101 video series. Before we get started, if you scan the QR code at the bottom left of the screen, you'll be able to connect with me on LinkedIn. Over the course of this video series, we'll be taking a look at the building blocks of a BigFix FixLit. By the end of the series, you'll have the tools you need to create basic custom content in BigFix, as well as some pointers to more advanced methods. In the first video, we looked at basic commands like prefetch, extract, copy, move, and wait. In the second video, we expanded our abilities by learning about overriding the wait command to change its behavior and arbitrarily creating text files using createFileUntil. At the end of the second video, we had a working FixLit that set my desktop background to a picture of one of my cats. But like I said at the beginning of the first video, I have two cats, and I want the FixLit to prompt me for which cat I'd like to make my desktop background. To do that, we'll round out our skill set with a few more commands: flow control like if and else, relevance substitution, and parameters. ActionScript has support for very basic flow control. You can specify what should be done if a certain condition exists, and specify an else statement for what to do if that condition's not met. Unlike relevance, you don't need to use the then operator for something to happen. Just make sure you end your if statements with end if. The condition the if statement evaluates is written in relevance. This is done using a concept called relevance substitution. If you put text between two curly braces in ActionScript, it'll be evaluated as relevance. A simple example would be using if bracket Windows of operating system end bracket to specify what a FixLit should do if it's running on Windows. Relevance substitution opens up FixLit writing to a world of possibilities, especially when used in conjunction with createFile. I'll point out several places we use it during the demo. Finally, we'll make use of a parameter to store the name of which cat I choose. Parameters are kind of like variables and are called using relevance. You can define a parameter in line in the course of a FixLit, and can even make a parameter equal to the output of a relevance substitution clause. In our case, I'll demonstrate how you can prompt the operator taking an action on a FixLit for its value, then use that to shape what the FixLit does. By the end of this video, we'll have a fully built FixLit that uses a parameter to prompt for which cat we want, uses flow control to get the right picture, uses relevance substitution throughout to make sure we set the right picture, and uses a append file to create a running log along the way. Before we get into the demo, I just want to point out that there are additional ActionScript commands that we won't have a chance to cover in this video. The BigFix developer site can give you more information about these. Let's finish up our FixLit. In the last video, we got our FixLit to a place where it set my desktop background to one of my cats, but as you may remember, I have two. I need to be able to choose which cat should be my desktop background at the drop of a hat. To do that, we need our FixLit to be able to prompt us for the name of the cat. I also want to add in some basic logging around which cat was chosen. I've uploaded a picture of my other cat, Jaden, but as you can see by the name here in the prefetch statement, I didn't actually name it after him. It's just a generic name. We'll deal with that in a bit. The first thing to do is create a parameter to store the name of the cat. In this case, I want the operator taking the action to specify it, so I use the action parameter query command. At a minimum, you need to specify the name of the parameter. In our case, cat. I've also added a description for the prompt, which will ask the user the question they need to respond to. You can also add a default value that autofills the prompt box, but we don't need to do that here. Next, I've used some simple flow control to determine which image to download. If clauses evaluate if their relevance is true or false. Here, we ask it to evaluate if the parameter cat, cast as lowercase to account for different capitalizations of a name, is equal to the string Jaden as lowercase. If so, we download one picture and extract it. If not, we extract the other. We could do more error handling here, but I'm not going to worry about it. The next new bit is this append line file. Throughout the FixLit, I'm using append file to create a running log of what the FixLit does. In each case, I'm using relevance substitution, which you can tell by these little curly braces and the pink text, to create the line. In each one, I cast the object now to a string to get the current date and time, and use the ampersand operator to add more information after it. Here's a quick example of what I'm talking about in the FixLit debugger. If I do now, it gives me a time object. If I try to use the ampersand operator to add a string to the end of it, I get this error that concatenate is not defined. It's mad because these are incompatible types. If I cast now to a string, all of a sudden we get it. We get the current date and time, and then our hello string appended here at the end. Because there are now two options, I've decided that I want to handle that by renaming whichever I choose to cat.bmp and then setting that in the registry. To do that, I put together a piece of relevance to return the path name of whichever file is in c/temp and has a name ending in bmp. This relevance isn't perfect. It doesn't account for situations like having multiple files that meet that criteria, but it'll do for our needs. On the line above right here, I'm using append file and relevance substitution to note which file got renamed. So here's the append file, here's the move command that's going to rename it. From here down, the only other new pieces have to do with logging. There's an additional best practice deletion of deleting c/temp/catlog.log in case it exists. And then down here, one final append file that the script has finished running. Note that if we had used run rather than wait to run the script, the timestamp in our log would not have accurately reflected when the script finished running, because it would have run the command right after it kicked off the script, rather than waiting for it to end. Finally, we copy the append file to the log. Let's run the FixLit, enjoy the new cute cat pic, and check out the log. When I take the action, it prompts me for the name of the cat. For the sake of argument, I'll put it in all caps. Remember, we cast it to lowercase before, so it shouldn't matter what I put. We'll take the action and sit back and wait for our cute cat. And there he is. Just a few moments later, we've gone from one unbelievably cute cat to another, and now I can do this whenever I want. One last thing. We need to look at the log to make sure it accurately reflects what our FixLit did. And it does. Here's the time, what we selected, which image it renamed, the fact that it set the value in the registry, and the fact that it finished. So hopefully this was a useful intro to basic and intermediate ActionScript concepts. Once you master the building blocks, you can solve just about any problem with a combination of the power of BigFix and some creative thinking. That's the final video of our ActionScript 101 series. I hope you've gained a better understanding of ActionScript and expanded the toolset you have at your disposal to create custom content. This slide has links to additional support resources. Thanks for watching.